I'm just playing. I'm not finishing the entire thing. You guys are in the back of your homework spiral for anyone joining us just now. Working on a couple problems in groups, trying to talk through the steps, what to consider, etc. Thinking about the specific directions as far as what answers to give, but you have some work to do before even doing answers. Guys, are we trying to make this match 1? No. Well, we need to set it equal to 1, but we're just trying to change this up to make it a whole lot nicer to solve. Because if you remember from yesterday, really quickly, just giving you perspective, we want to get down to somehow getting the trig with the x alone. Now, this one we ended up saying none because square rooting a negative was never going to work. If we tried to square root one side, you have to plus or minus square root, but square rooting a negative is imaginary. So even though that does get the sign of x alone, there were no possible answers. But that one was good in that we were trying to get alone. This one, eventually getting cosine alone, now say unit circle. So we're stuck because we need to get somehow a trig function alone in this problem. But it's messy to begin with. So I don't know, just thinking about it a little bit and trying to change how it looks, I think I would go to sines and cosines, hoping that would help me out a little bit. Plus, I don't really want to go to the unit circle thinking secants and tangents. That's hard. And if you do like a quick substitution, oh, hey, they have common already. So can't we just do 1 plus sine over cosine is equal to 1? And then 1 plus sine. Come on, you know what I'm going to do. You've had me long enough. What am I going to do if there's division? Multiply. Huh. Now what? You could subtract sine. But then you have something equal to 1. I want factors equal to 0. That doesn't work. What else, Tony? Square both sides? Yeah, we could square both sides. Why on earth would Tony think of squaring both sides? I can't plug in for cosine to get sine, but I can plug in for cosine squared with a Pythagorean property. Wait, where'd the 2 sine of x come from? Foiling. Ooh, maybe some of you guys can now keep going. That cosine squared can be a 1 minus sine squared. That cosine squared can be a 1 minus sine squared. We can combine like terms, and maybe factor 0 is a possibility after all. Subtracting 1, what happens? Cancels. Adding sine squared, what happens? Yeah. Why am I writing the sine squared first, do you think? Order. Yeah, descending order for like polynomials. We do the squared, then the single, then the constant. Oh, the constant disappeared. It's not even a trinomial like that guy. Ah, what's in common? 2 sine of x. What's left when you pull that out? 1 sine x plus 1. Yesterday I was like, don't be afraid of factors. We like factors, because what can you do with factors when they're equal to 0? Set each one. Remember factors? We don't mind those. Factors are okay. Set each one equal to 0. So then I either get dividing both sides by 2. Sine of x equals 0, or subtracting 1, sine of x equals negative 1. Hey, is that something that happens in the unit circle? Uh-huh. Now, are some of you good at thinking about how sine is the y, and the y will be 0 when you're flat on the x-axis? Which happens at 0 or at, wait, what are the directions? Do they want infinitely many? All possible plus 2 pi n or plus pi n? Nope. Just negative pi and pi, huh? So they're only asking for going up 180, up pi, and down 180, down pi. Oh, okay, well hold on, 0 and pi work, right? Were they closed intervals? Am I allowed to choose pi? Am I allowed to choose pi? No, but is 0 working? Is negative pi working? Yeah, okay. So since y's will be flat on the x-axis, 0 works, pi is too big according to that. Negative pi, though, works. So far I have x equals negative pi and 0 from this guy. But when does sine equal negative when? When is the y negative 1? So I need to think about this location, and this location, and this location. Here, my y's were 0. And here, my y was, so those are both my cases. I can't go around the positive way because 3 pi over 2 is too big for my interval, so I'm just going to say x is equal to negative pi over 2. And that would be my final answer. I'm just going to write it in numeric order because it's a little bit nicer that way. Probably what the book also does. Dun, 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 dun. Gavin. Oh, this is just the unit circle. And the signs are the y's. And so the y's are 0 at 0 and at pi, but also at negative pi.
So when the sign is 0.
Mm-hmm. So if you want to, if it helps, I'm not sure if it'll help many people, you can think about sine inverse. So the idea to get x by itself is I need to go back. Now the problem with sine inverse is your calculator only gives you one answer, that there's that whole like restricted range domain. It would only give you one answer, and I'm looking for more. So I have to be careful not to get stuck in only looking for one. But you're thinking of when does sine equal 0 there and there.
So if negative pi is 0 because those are the only points where y is 0.
Yeah. And technically pi and 2 pi and 3 pi and 4 pi, but pi wasn't allowed or anything bigger or anything smaller. Good. So what have you guys started doing over here in number 61, if you've started, just to kind of collaborate as a class now? Well, yeah, it says quadratic formula. Well, I guess that's important. Maybe we should kind of review the quadratic formula. Isn't it normally x equals negative b plus or minus?
All over it.
How many of you the song actually helps to some degree for you to remember? Okay. X equals negative b plus or minus square root b squared minus 4ac all over 2a. But that only x plus c equals 0. Is this exactly what I here? Kind of. But is x being squared, and is x being by itself, and is x being not there? No. Who's being squared and by himself, single, and then with a constant alone and not the term at all? Tan. So I can actually change this formula with e to the x, and you kind of put it down. The formula can go with a anybody squared plus b anybody, that same anybody, plus c equals 0. And you set negative b plus or minus square root b squared minus 4ac all over 2a equal to that anybody. So who anybody is this one? Uh-huh. So I'm going to say tangent of x is equal to b plus or minus over, go. Plug into the formula. And then after you plug into the formula and try to simplify down with squaring and subtracting after multiplying, square rooting, negative b plus or minus whatever that square root is, dividing by 2a. I want you to be asking yourself the question, is this somewhere in the unit circle? Tangent, sine over cosine, tangent, y over x. Plug into the quadratic formula. Come on, Robbie, you got this. Plug in A, plug in B, plug in C. You can plug in A and B and C, right? You can still collaborate in your groups. Some groups are doing that. Good job. You can still collaborate in your groups.
I'm stuck now. This is backwards. This is forward. That's like right here. No, be backwards. Yeah, right. Actually, is your calculator? Miss D, are we looking at your calculator?
I think it's unit circle, but if not, I suppose you could try.
Oh, if it's a decimal? I don't know if anything that's -3 plus 5 over 2.
I hear people going to the calculator, so maybe it's not unit circle. Let me come up and plug in. I was giving you guys a chance, just in case. All right, I'm playing. Ooh, because it's a decimal. So wait, how do you use your calculator to do this? Because that was part of homework also, was using a calculator. At least one calculator out per group, making sure everyone can see what you're doing. Some of you figured this out last night and some of you did not. What mode should you be in? Almost all of homework. Radian, good. Almost all. Not special units, sadly. Sadly. There are a few different ways of doing it, but probably the most straightforward way would be to make this guy y1. y1 equals tangent of x. Make this guy y2. I have y and y. I have y2. Plus or minus. Uh-oh, not just y2, but also y. Oh, struggle. Struggle. To do y2 is -3 plus root 5 over 2. y3 is -3 minus root 5 over 2. And what are you looking for when you graph? Intersections. Good. So when you graph, you're looking for intersections, and you're going to be able to use that second trace menu, right? gradient mode, plugging in y1, y2, y3, looking for intersections. The y2 and y3 should be two different horizontal lines, and they should go through your tangent. Well, wait a minute. Hold on. They want all solutions. They want all solutions. The struggle with all solutions is you have to add 2 pi n to everybody, right? However, if you guys realize that if tangent equals, say, a positive number in the first quadrant, where else will tangent equal the exact same positive number? Third quadrant. How far away is the first and third quadrants? How would you go from one to the other? 180, or in radians, add pi. How would you go from the third quadrant back to the first quadrant? Add another pi, and then add another pi, and add another pi, and another pi, and another pi, and another pi. Technically, what you could do for these is you could actually find one section with the y2 and then add pi n. Because pi n will get you quadrants where this could possibly be true. And then you could find one intersection with y3 and do the exact same thing plus pi n. So who did find an intersection with y2 with negative 3 plus root 5 over 2? Kyle, what'd you get? Still checking it out. Okay, can I get someone else on finding an intersection with tangent and negative 3 minus root 5 over 2? I had a lot of people with their calculators. What happened? What happened? What happened? Kathleen, you have yours out. Can you go ahead and just do tangent of x with negative 3 minus root 5 over 2? Oh, you have colors though, right? Color-coded? Oh, bummer. Why don't you take away or deselect, either erase or deselect y2, because we'll get the y2 from Kyle. Yeah, take away the plus one. There you go. Yeah, true. It's harder without the colors. And just find me the intersection that's like closest to the origin. Like there might be some that are far away. Find me the one closest to the origin.
Well, look at the x.
The x. Negative 0.36. Is that 4 or 5? I didn't look at the last. Okay. Negative point.
I also found that doing math. I did a negative 10. I did inverse tangent.
Oh! You could have just done inverse tangent of each of them from the home screen? Does anybody want to try just to be ready for Kathleen when she finds it? You can do tangent inverse of both sides. Anybody want to go to the home screen and do tangent inverse of negative 3 minus? It should match what Kathleen has. Kathleen, what do you got? Ooh, so is tangent kind of cool because you can just add pi n, so maybe you didn't even have to use your intersections? Why am I saying tangent inverse again? How do we get to x if we have a tangent on the outside? Yeah. The only problem with tangent inverse, though, is that he only gets one answer, but didn't we just talk about how if you have were these tricky? Yeah. Were they super easy? No. No, that's good. They're both part of the answer. Sorry, I'm a little confused as to why that's a bad thing. Is it a bad thing, bud? Oh, yeah. Yeah. No, that's exactly what we're supposed to do. We're supposed to find all the possible solutions, so we have to think about both. Does that make sense? Yeah. So I'm going to box both, too. I have both. Kim.
I got to the last step, but I don't know how you do the circles and then you say it's 3 that.
Oh, no problem. Here you go. Guys, you know where the unit circle is, right? In section 4.2? Now, should you know this forwards and backwards? Yes. Do you have to be able to know when sine equals 1/2, or when cosine equals negative root 2 over 2, or when tangent equals 1? Yes. So Kim, as I said when we were talking about it, sine is the y value. So go around and say, when is y 0? Oh, right there, at 0. When is y 0? Oh, right there, at pi. When is y negative 1? Oh, right here, at 3 pi over 2. But did you write down the directions?
This
Now that's a closed bracket, not an open bracket. No, no, no. That's a closed bracket, not an open bracket. So you wrote that down wrong. It's not allowed to equal pi, so pi is not an answer. It is allowed to equal negative pi. So negative pi was an answer. 0 was an answer. Not allowed to be 3 pi over 2. Too big. But is allowed to be negative pi over 2. Okay. With that, that one was using a grapher to approximate solutions. The nice thing is we just did that, so let me get rid of that page. And this is one more kind of weird one. But I need you guys to help me out as to why this is weird. Let's actually go to our this one. Actually go to our notes for this one. Well, no, in the back of our homework spiral. It's all right. You guys are already there. If you want to put it in your notes, you may. If you want to go in your homework spiral, you may. It's a weird type of problem. We're going to actually be grading this one tomorrow because even though I know the majority of you had it totally ready to go today, when people were walking in this morning, right away I started getting questions about I didn't understand. So we did a few example problems, and those few people that might have written something down and had no clue what it meant, maybe you could go back and work a little bit more with homework. We are going on to section 5.4 today where you can start homework, but some of you still need to finish up this one because you didn't understand, and hopefully the examples help. Real fast, Austin. Okay, that's actually what I was saying with tangent, and we'll see it kind of again in this problem. Tangent, we could have found lots of intersections for the first quadrant, second quadrant, third quadrant, fourth quadrant, and we could have said plus 2 pi n, plus 2 pi n, plus 2 pi n, plus 2 pi n, but that gets really tedious. So instead of, like, if there are lots of different places, especially in problems where you get something like a plus or minus with a square root. Ooh, people who were working on homework today, help me out. Plus or minus with a square root. There were a couple of these. If you had something like sine squared at the end is equal to 1/4, for instance. How would you solve for sine? Square root. But when you square root is squared, that's absolute value, so 10. The square root of 1 is 1. The square root of 4 is 2. How many quadrants will sine equal plus or minus 1/2? All quadrants. Because plus or minus says, I don't care which quadrant, give me all of them. Now, hold on, just a few of you who were like, and that's kind of Kim's question. She was like, well, I got the math, but I didn't know how to finish to the answer. That might be a few others of you as well. If your unit circle is popping into your head, sine is 1/2 at pi over 6. Cosine is negative root 3 over 2 at somewhere in the second or third quadrant at the pi over 6's. If that's not popping into your brain, this could be very, very hard, and you might need to start using the cheater chart. Because the cheater chart has a song just like the quadratic formula. I'm coming back to your question, Austin. The cheater chart has a song just like the quadratic formula. It's kind of basic. The most complicated pieces, which are the in-between. Because it just goes 1, 2, 3, 3, 2, 1, all over 2. And awkwardly, there should be a square root, but that's not a part of the song, and so I put it in myself. Square root of 3 over 3, 1 square root of 3. Wait, what's missing? Oh, sine counts up, so I'm missing 0, I'm missing 1. Cosine counts down, so I'm missing 1, I'm missing 0. Tangent says divide. Tangent says divide. Why am I saying that?
Whoa.
1, 2. Oh, square root of, that's kind of awkward. I know, I apologize. Square root of 3 over 3. 1 square root of 3. It's all from Luca. He could sing in choir, but it was kind of funny when he sang the chart. But anyway, it still works. Still works. Why am I saying that? At all the pi over 6's. Wait, which ones? Oh, positive, negative. All of them. Well, who are all of them? Well, here we go. I could do pi over 6 plus 2 pi n. That's part of the answer. Second quadrant, 5 pi over 6. I could do 5 pi over 6 plus 2 pi n. I could do 7 pi over 6 plus 2 pi n. I could do it. But the book is like, I'm lazy, and I'm lazy too. I don't want to write him and him and him and him plus 2 pi n plus 2 pi n plus 2 pi n plus 2 pi n. So instead, I see a pattern. And the pattern says, if I do pi over, couldn't I just add pi and also get 7 pi over 6? So I can cheat and say, haha, less work if I do pi over 6 plus pi n. I'll get him and him. Now I'm not done, but it shortcuts it. So I could do this plus 2 pi n and that plus 2 pi n, or just do this plus pi n. And then same thing here. I could just do 5 pi over 6 plus pi n, which is also true, but I'm lazy. So instead of doing 5 pi over 6, I'm going to use this guy, 11 pi over 6 plus pi n. That doesn't help. Well, check it. I could do plus or minus pi over 6 plus pi n and write that answer a lot faster than 4 different angles plus 2 pi n. So what are they doing when they use n's in the back? They're shortcutting the process to not have to write as many answers. Is that cool?
Could you theoretically speaking pi over 6 plus pi over 2?
No, because pi over 6 plus pi over 2, think that's a 90-degree angle. That'll end you at pi over 3, sadly. All right, guys. Come back, come back. Shh, shh, shh. Focus. Why is this one hard?
Because there's nothing.
What happens when you add 2? Oh, stink. What did Tony do last time we saw something like this with a sine on one side, a cosine on the other? You have to square it to use your properties or your identities. But wait. Look at your chart. Isn't there only one place where sine and cosine are the same? You could actually cheat a little bit and be like, it's the pi over 4s. Could you square both sides and use the Pythagoreans and move them all to one side and plus or minus square root? Yes. But there is sometimes, every now and then, you might not have to go all the way with identities and say, oh, that only happens at pi over 4s. Wait a minute, wait a minute, wait a minute. Okay, I'm using the restriction again. Pi over 4s. Which pi over 4s will sine and cosine be the exact same? All of them. No. Sine alternate, and cosine's negative when sine is positive, and cosine's positive when sine is negative. Which quadrants will they be the same? 1, because they're both positive, and 3, because they're both. So Austin, what am I going to do? First and third? I could do plus 2 pi n and plus 2 pi n, or, yeah, or, won't the pi n sense? Good. Kiddos, once again, we're grading this homework tomorrow. Just a few of you have a little bit extension of grace to try to actually understand maybe the homework that you wrote down in your homework spiral. No resubmissions or anything. Oh yeah, we'll talk about that later. No resubmissions. Let's get rid of that. Oh my goodness. Hi, computer. Wakey, wakey. All right. But let me introduce you to the end of chapter 5. Because the end of chapter 5 is sections 5.4 and 5.5. Maybe 5.6. On the calendar, we're still doing fine. Here's the idea with the rest of chapter 5. 5.1 says, guess what? You can play with trig by factoring and common denominator, adding and subtracting and distributing, and I don't know, what else did you do? Subtracting? 5.1 said you can play with trig algebraically, or we would say analytically. 5.2 said Right, 5.2 says, hey, you can change nasty expressions to be a lot simpler. 5.3 says, all of that was for the purpose of being able to solve equations. conditional equations. Oh, unit circle came back. 5.4, 5.5, and 5.6 say, now that you've learned the basics, that you can add and subtract and multiply, simplify, factor, common denominator, transform, solve after transforming. Now that you've learned the basics in 1, 2, 5, 3, with only the basic formulas, circle, quotient, Pythagoras, and even and odd. You've learned how to do all of this with the basic formulas. We're going to start to take the blinders off. You've been so zoomed in on only those formulas from 5.1. It's like, no, 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 there are all these other formulas out there. Can you do what you were doing in 5.1, 5.2, 5.3 with new formulas also? So here's the all these sections, I'm not teaching you any new procedures. I'm just saying, how do we do the old procedures with new procedures? I'm not teaching you any new procedures. I'm saying, how do we do the old procedures with formulas? What do I mean? How do we plug in to trig with new formulas? How do we do 5.1 skills with formulas? How do we do t-proofs with new formulas? How do we solve equations with new formulas? It's all the old stuff. This is section 5.3. How do we do 5.3 with new formulas? This is 5.2. How do we do 5.2 with new formulas? This is 5.1. How do we do 5.1 with new formulas? This is, I don't know, unit circle? With trig, but that didn't start until chapter 4. So maybe chapter 4. So I'm not going to teach you like, hey, this is how to solve an equation, or hey, this is how to do a t-proof, or hey, this is how to factor or get common denominators. Instead, this is we have new formulas, let's use them. Now, you guys already see my note, my warning off to the side. Trig functions don't distribute into their arguments. Trig functions don't fold in on themselves, but a lot of you would think they do. How do you do sine of u plus v? Oh, easy, sine u plus sine v. No, sine can't fold into itself. It's sine of, not sine times. I should say it's sine of, not sin times. No distributing sin. Hey, life lesson. Anyway, don't spread the sin. Don't be part of the problem. Be part of the solution. I don't know. We can do all kinds of pithy sayings, but no distributing sin. That's illegal. It's not valid. And they're going to have you do some things in homework where it's like, hey, plug in. Does it work? And you're going to be like, no, it doesn't work. If you plugged in sine of 30 degrees plus 45 degrees in your calculator, it would not equal sine of 30 plus sine of 45. That's not true. It's not valid. It doesn't work. These formulas, just like the identities we talked about before with tangent of x being sine of x over cosine of x, or 1 plus tangent squared of x being secant squared of x. Those ones are true and must be used. Same thing here. To do sine of u plus v, you have to do sine u cosine v, switch it, cosine u sine v. Now, I have little things over here off to the side as far as how I remember it. These are little clues. I know they're silly clues, but they're, I think, good clues. Sine, same signs. Cosine, signs change. So if I have an addition for sine, it's going to be an addition. If I have a subtraction, it's going to be a subtraction. For cosine, addition will be subtraction, subtraction will be addition. But here's another way of remembering it. What does the prefix co stand for? Well, co-function, but just in English. Doesn't co mean with or together? Who's the cosine with or together? The cosines are together and the sines are together. Oh, hey, maybe English can help us every now and then in math. So cosine of u plus v, the sum and difference formulas. Cosine will be co minus sine. Or cosine of u minus v, co plus sine. Whereas sine says, nope, nope, nope. Got to keep them separate. So b plus b sine. Oh, can't be a sine. It's not with or together, so cosine, cosine, sine. Anyway, that's just a way of remembering. The cool thing is when you get down to tangents, isn't tangent a sine over a cosine? Same over change. Now you have to memorize what goes where, but same over change. The sine stays the same and the sine changes. That's kind of cool. Sine stays the same and the sine changes. Anyway, all the kind of cool ways of memorizing the formula. But here's the struggle. What you're going to have to do with the formulas. Use them. So can I give you a peek at how you're going to use them? Just a peek. You can't write it all down. We're going to have to go through it tomorrow and make sure it makes sense. But just a peek. Oh, that peek, I don't like that peek. That peek shows how it doesn't work. I like this peek better. Hold on. Oh, I don't like that peek either. Lame sauce. Lame sauce. Oh, look at that. Wouldn't that be awful?
Oh, dear Lord.
Unless this is the same thing as tangent of u minus v. Ha! This is the same thing as tangent of 2 pi over 3, which square root of 3 over 3, 1 square root of 3, negative because it's in the second quadrant. Dun, 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 dun.
I
Bye.
like that. I like it a lot.
These formulas make hard things simpler.
But
We'll see what that is later. Bye. Finish up 3. 5. Sorry, section 3. And maybe start making formula cards with 5-4.